In the last video about IAM, we discussed who can access your data platform, but it doesn't really mean that we can control what exactly they can see yet. Today we are going deeper than just IAM, and we are going to investigate what is row level security, column level security, and dynamic data masking in Microsoft Fabric Warehouse as an example. If IAM controls the front door, then row level security, column level security and masking actually control what people see after they get into the building. Now let's discuss what is data level security in general. Basically, it restricts user access to specific rows, columns or subsets of data within your warehouse, and it ensures that the users only see the information that is relevant to them. It acts as a precise and a granular layer of protection, so you can think of those row level securities or column level security or dynamic data masking or the object level access that we are going to discuss, and those basically prevent unauthorized access and they enhance data compliance, for example the GDPR or HIPAA, and on top of that it protects the sensitive intellectual property or the private information. If there would be data breach, then you can have those extra controls on top of just the data being available blankly for everyone. It would help you to mask and prevent the complete data exfiltration, potentially. From all of those data level security controls and techniques, row level security is number one. What is it? Basically, row level security filters rows based on who the user is or what are their attributes that are available. You can think of that as a always attached where clause to all of the queries that you run, and basically it will limit the amount of data that would be returned to your user. The good example use case where it can be helpful could be that you have a big data warehouse and you have multiple regions. So for example, someone from Europe and another sales from United States. And the sales managers of each of those regions, they should be able to see the data only from their own region, and they shouldn't be able to read the data from their neighboring store. That is a good example where this can be implemented and when it can be useful. To put it simply, the table is the same for everyone still, but the query results different based on who runs the query. Number two, the second control or technique that could be implemented is a column level security. It restricts access to specific columns in your table, and the example use case could be that with let's say those sales managers, yet again it can hide the cost price of each individual item, but it will still allow to have the sale price. Or if it is some sort of a PII information, personal identifiable information, then those can be hidden completely from the sales managers because they don't need to know what is the email of the customer, just what is their purchase. So in other words, you can still query the table, but some of those columns are off limits completely, and it is especially relevant in analytic platforms where sensitive fields they do exist along the non-sensitive ones, and you don't want to be able to query everything all the time. Number three is a dynamic data masking, and what is it? It is simply what it sounds like. Data is not blocked to be available for the customer or for user who runs a query, but instead it is obfuscated. So the good example would be for the credit cards, for the sales managers database, that instead of showing the full credit card number, it will show you only the XXX, XXX 1234, so last 4 digits of the credit card. Or the emails can be shown as stars@stars.com, something like that. So the important distinction with the column level security is that data still exists, but it is masked at the query time for specific users. If you have access to unmask the data, then you would be able to see the full data as is, but if you don't, then you can have only the masked version of it. It can be very helpful for the support team. So imagine you are a developer and you have to run some debug queries on production-like data. You don't need to know what is the actual email address, that it's just there. You might need to compare that the email addresses are different, but you can do so using, for example, the hash of the email address itself. So it basically adds the audit access if you need to, without full exposure to the data itself. With all that being said, let's jump into the demo. As usual, as previously, I have two users created. One of them is Fabric user, who is a main administrator, and I'm going to run all of the control setup using this user. And then I have my Guinea pig, who is a Fabric secondary, and he is going to run only two simple queries. Try to select everything from customers and try to select the first name only from customers. Now back to the setup. What I have is basically we can control access to the warehouse for this Fabric secondary user, for my secured warehouse, which is this one, using object permissions. So only for this one I added Fabric secondary with read data and read data. So how it is done, it was simple as that. So we have Fabric secondary, and I added only the read data permissions for them. Then I can grant them, and that's what you would end up with. Important distinction is that for the workspace itself, I haven't added any level of access for the Fabric secondary, and if we are going to go back to this person and try to open workspaces, let's refresh the page. Yep. So for workspaces, they still have only access to the consumer workspace that was left from my last demo, but still they can access the specific endpoint of the warehouse, because data warehouse, because that's what they were granted explicitly, nothing else. So in order to access it, they would even need to know the ID of the warehouse if they want to use it from the browser like this. Next, what we can do for this setup, I'm going to create a table customers with customer ID, first name, credit card, last name, phone and email as columns, and insert just two rows into this new table with John and Jane being two separate customers with some data inside of that. So if we go now to Fabric secondary and try to query everything, it will give us once again everything. So we have two customers that we just created with emails being visible, credit card being visible, first names, etc, etc. And the first thing that I wanted to highlight is we are going to implement the column level security. In order to do so, the first thing that we want to do is actually deny select on customers. So we deny the whole table for this user. When we add this permission, we can double check what is on the permissions, and we would see that they can connect still to the object, to that database, but still they have deny on select. Now if you will try to run the same query on the select customers, it will fail with a policy being denied for that table. Let's fix it, and now we can grant select only in a subset of fields. So we allow selects on custom ID, first name, last name, phone and email, but credit card is not in that list. Let's try and run that same select star from customers yet again. This time the exception is different, and you can see that the select permission was denied on a column credit card explicitly. And if we would try and run select first name, then we can easily query only specific information that we need to have access to, but the whole data is not available for us. And while we know that the column name is credit card and can infer what the information that is missing, but we cannot get access to that information. And that is pretty much the idea of a column level security. The data does exist, and this person who manages the table, so let's run another query, start from. For this user, it has access to everything, and the credit card data, it is still physically available, but only for those who have access to that one. Let's clean up after this one, and in order to clean up, we need to revoke select, and that will remove all of the restrictions and all of the additional conditions on the select. And if we will check what is the current state of the permissions, we will see that they have only grants, but on top of that they do actually have select permissions. So now we can double check that they have access to all of the data from customers, and yes, they do, as well as just to individual first names or last names, etc. Next level that we want to touch base is a role level security. And here I will make another detour and discuss briefly that a good practice, just as a rule of thumb, to not manage those permissions on an individual level. So the way how we did it for the column level security with grant select on yara yara for this individual user email address, it's not a good practice, it's actually a bad practice, and much better to do it using roles. So you can create roles on a database and then manage permissions based on the roles, and after that assign roles to specific user. I already have those two created, the John and Jane role, and the idea is that I'm going to add my user Fabric Secondary to the John role, and only to the John role. And after that I want to create this function. I will come back to this in a second, and based on that function I am going to create a security policy. Using those security policies, that's how we manage role level security. And as I said in the beginning, it actually adds a filter predicate based on this function, and for that function we pass the first name as parameter from the customers table. And what is that parameter? Basically, on a name I am checking that if the parameter is John, then I want to validate that the user, the current user who is running the query, is a role member of a John role. So there is a match between John role and the name. It's just a stupid example that I come up with, and in real world scenario it would be different, but it gives you a good illustration of what I want to achieve. So the same is with Jane role and Jane name. With all of that being implemented now, we can come back to our Fabric Secondary and try to run select star from customers. It will return only a single role, John, because he is a member of the John role. If we go back and try to remove him from the John role, so he is not a member of John role and the Fabric Secondary is not a member of Jane role. In that case, if we run select star from customers, the results will be empty because he has access to no data at all in our database at the moment. So this is the illustration of row level security. Let's clean it up yet again, and in order to do that, we need to drop security policy on the table, and that would be enough. With it, we can go and select star from customers and see the whole data as it was before yet again. And the last thing that I wanted to highlight is dynamic masking. In order to do that, we can add masked code to specific columns, and there are multiple different functions available. I have them available, and I will link this article from Microsoft documentation. Basically, that's how the dynamic data in Fabric dynamic data masking in Fabric is done. There are multiple options for the dynamic mask, and you can have the default masking, you can have the email masking, and you can have other ones on top of that. They all follow different use cases, and let's try and implement the email for now. So we are going to alter the table customers and add this mask on an email column. When this is executed, we can go back to my Fabric user and try to query customers yet again. So the new result would be that email comes up as jxxx@xxx.com. Let's highlight it actually with only a single column so it is easier to see. So like that, the data is masked. But imagine that the Fabric secondary actually is an elevated user, and he does need to have access to that email for some reason. So he might be part of the marketing team, and they will need to send cold emails to those customers. Well, maybe not so cold anymore. In order to grant access to the data, we need to grant unmask privilege on customers for Fabric secondary, or once again it could be granted on a role, which would be a better solution for this. And now if we run that same query, we will get unmasked and real data as it was before. Okay, so I hope that illustration was quick and easy to follow. And once again, to rephrase what we just saw, is that row level security changes which rows exist in your result. Column level security removes columns entirely from the result set, and masking changes only how values appear, but not the availability of the data itself. And in most real-world data platforms, IAM is not enough to implement a fine-grained level of access, and the real complexity starts inside the warehouse, not on the entrance to this one. Alright, that was it, so please stay tuned, like and subscribe to my channel. See you!